Students, this is Unit 7, Circles, Lesson 7.1, Circle Parts and Central Angles. You want to get the date, time, location that you're watching this video. Students, please don't try to multitask while you're working on this video. Focused attention equals faster work. Let's go ahead and recap something from semester 1. We're going to graph a line perpendicular to this given line, y equals negative 3/4 x plus 4, that goes through this point. Let's start by graphing the given line. Our intercept is positive 4. Our slope is going to be negative 3/4, so we know this given line is downward from left to right. So that is our given line. The two qualities of the second line is the fact that it's going to go through this point, negative 2, negative 4. And it's going to be perpendicular. So let's start by graphing y equals mx plus b. Step 1, our perpendicular slope is going to be the opposite reciprocal, which is 4/3. If our given is negative 3/4, the opposite of reciprocal is 4/3. Our x is going to be negative 2. Our y is going to be negative 4. Do you recognize this? We did this several times last semester. And now we solve. So right here we have b. This is going to be negative 8/3 equals negative 4. We're going to add 8/3 to both sides, and we're going to change this into negative 12/3. And this is negative 8/3 plus b. So we add 8/3. Negative 12 plus 8, negative 4/3 equals b. This is easier to graph if you change it to a fraction, which 3 goes into 4 one time with 1 left over. So that's 1 1/3, and it's negative. So the equation of the new line, the secondary line, is going to be y equals 4/3 x minus 1 1/3. Go ahead and let's graph. I know many of you are very uncomfortable with that 1 1/3, so I'm going to take this very slowly. We're going to go 1 and about 1/3 right there. And we're going to go 4 units up and 3 units over. So that's approximately 2/3, 1/3, 3, 4, and then 3 over. 1, 2, 3. Graph your second line, and you will see that that perfectly aligns. It makes a right angle. And we go through our target point, which is negative 2, negative 4. Don't be afraid of fractions. Fractions are part of life. We're going to be learning about circles over the next 3 weeks. Circles. And there's lots of new vocabulary this first time. Let's read and check these new vocabulary points. Read and check. Circle, radius, diameter, central angle, minor arc, major arc, semicircle, concentric, chord, secant, tangent, measure. Probably going to find a straight edge very helpful today, and colors would also be helpful. So first we're going to talk about the anatomy of a circle, key terms. First off, we name the circle, so the physical circle, of course, is this edge, but we name circles by their center. I'm going to put a little center there, I'm going to call it point Q. So the shortcut for naming this circle, we use this symbol, little circle with a dot. We put a dot in the middle so that it doesn't look like a 0 or an O. That would be the symbol for circle. And then Q, that names the whole circle. We name circles by their centers. The radius of a circle is like a spoke in a wheel. Radius, center to edge. A diameter goes all the way through a middle, all the way across. In other words, it's 2 radii together. That would be a diameter. The diameter has its endpoints on the circle. A chord is any segment with endpoints on the circle from the inside. A chord is any segments that have endpoints on a circle. Tangent. Tangent is a segment or a line that just touches the circle at one single point. That's a tangent. Where that line touches the circle, that's a point of tangent C. A secant is if a tangent intersects a circle at one point, a secant at 2. A secant can be any segment or line that starts from the outside and intersects a circle at 2 points. That would be a secant. It can go through and stop at the far side, or it could go all the way through. But what makes a secant is that it intersects at 2 points, starting from the outside, whereas a chord is inside and endpoints on the circle. That's lots of new vocabulary that you need to be familiar with. If you need to, pause the video, say each of these new words, describe to yourself what they are, and then move on. Pause the video. Welcome back. You see, now we're going to use these parts of a circle. Right under here, you're going to name each one of these. Do the best you can with the symbols. I'd rather you guess and then switch to a red pen and correct. Do this page on your own. Pause the video. Welcome back. Let's see. Okay, so we name the circle by the center, so we would call this circle A. A radius is any segment center to edge. So AF would be 1. AH would be another, or HA, same thing. A diameter goes all the way across through the center. So HF, FH, same thing. A chord, endpoints on the circle. So I just do the segment, CD, the segment. I could also do DG. A tangent touches the circle at one point, so that would be segment or line. BJ, that would be a tangent. And H, of course, is your point of tangency. Secant starts from the outside of the circle and goes through at 2 points. So that would be BD, the line, that would be a secant. Check your work. If you were slightly off, make a little note. Okay, we need to talk about relationships within circles. Relationships within circles. So the first one is intersecting. Anytime two circles cross each other at 2 points, that's considered an intersection. If they touch at 1 point from the inside and outside, we call that tangent. Big bullseye, they share exactly the same center, exact spacing. So in other words, the radii here to here is the same, and the radii here and here is the same length. We would call that concentric. And then whenever you have circles with congruent radii or congruent diameters, automatically the circles themselves are congruent. Intersection of circles, tangent, concentric, congruent circles. Now that's relationship between circles. Now we're going to talk about relationships inside a circle. Here's some more vocabulary. An angle that is connected to the center is called a central angle. So angle BAC is a central angle because it is connected to the center. A piece of a circle is called an arc. And if it's less than 180, it's minor. A piece of a circle bigger than 180 degrees is called a major arc. And an exact half circle is called a semicircle. So we have specific terms for these. The minor arc, again, that's a piece of a circle less than 180. Part of circle, it's less than 180 degrees. So in this, we would say BC is a minor arc, and we only use 2 letters for minor arcs. 2 letters if it's less than 180. So BC or CB would be the exact same thing here. Major arc, more than 180. It's part of the circle edge. More than 180. Up here, we would name that arc B, D, C, going this way, B, trace with me, trace B, go through D, C, or you could name it starting at C, D, B, going that way. Either way, you have to use 3 letters. For a major arc, because you're going the long way around, you have to use 3 letters. Semicircle is exactly 180. It's half of a circle. Of course, that equals 180. We use 3 letters for semicircles as well. So this semicircle right here, half a circle, we would call that semicircle E, H, G, 3 letters, E, H, G going to the right, or we could call that G, H, E. Three letters. Central angles are angles connected to the center. So just go like this and then put a dot there and just write the word center. C-E-N-T-E-R. Think pizza slice. This would be a central angle. And we simply name it as we normally do with the angle symbol. And it's B, A, C, and we always put the center in the middle. That is a central angle. These are very important terms. We're going to be using them several times. So there's a couple very important properties. And we're going to start with the most simple one is this. That the degree measure of a central angle is going to be the same as the degree measure of its corresponding arc. Measure of a central angle to its arc the same. Yes, my friends, it's the start of another song. You'll get the rest of the song next lesson. Let's try it again. Measure of a central angle to its arc the same. So, for example, if the measure of angle, the measure of the central angle, B, A, C, let's say that is 70 degrees. I'm just randomly making up a number. Let's say this is 70 degrees. The degree measure of the arc BC, and watch how we note that. We say measure of the arc. It means measure of the arc B to C. Notice the arc symbol there. Will also be, therefore be 70 degrees. Measure of a central angle to its arc the same. So if the arc is 70 degrees, the central angle is 70 degrees. This leads us to 2 real simple concepts. If you have congruent angles, and that's the central angles, of course. If you have congruent central angles, then of course your arcs are also going to have congruent measures. Congruent central angles, you have congruent arcs. This one really simple. If you have adjacent arcs, you can add them. In other words, the measure of arc AD plus that notation, degree measure of that arc, whatever it would be, plus the degree measure of this minor arc, AE. Notice the little m there. If I add those arcs up, it's going to equal this larger arc, and it's a semicircle in this case, so we say DAE. Little arcs add up to big arcs. Like I said, these were simple concepts. Now we're going to use these simple concepts to actually do some angle measures together. Put your finger on it right there. Read this aloud with me. You read with 3 body parts. Your eyeballs, your lips moving, your finger on the paper. In the diagram below, EB is the diameter, and AF, AD, and AC are all radii. The measure of angle FAB is 60, and the measure of angle B is 55. Find all possible arc and angle measures. So work on diagrams. The first and most important thing for you to always spot are the diameters. And diameters, I want you to do 3 things to them. I want you to first trace them. Next, I want you to stretch them out. And then I want you to sweep the 180 degrees so it's easy to spot. Trace, stretch, sweep. Trace, stretch, sweep. Always find your diameters, trace, stretch, sweep. Radii, these 3 radii. Radii are always congruent in length, like spokes in a wheel. Now, knowing this, we have these angles. If this angle connected to the center is 60, the first thing you can do right there, measure of the central angle to its arc there. Same. So the arc F to B is also 60 degrees. This one right here, 52 degrees. Measure of a central angle to its arc there. Same. Let's see what else we can find here. We have 90, which would make this arc 90. Now let's see what else we can find. Let's trace something. Let's trace B, F, E. Do you feel that? That's 180. Now trace B to F. That's 60. So now I want you to find F to E. And of course that's 180 minus 60. That's 120. So you see, of course, that if that's 60, that's 120. Measure of its central angle to its arc the same. So this angle right here has to be 120. And if you look very carefully, we only have one lone pizza slice left here. One lone pizza slice. I'm going to give you a 20-second lead. I want you to try to figure out what that is all by your lonesome. I'll give you 20 seconds. Go. All righty, students, if you spotted the 180, then you can go like this, of course, and you can add 90 and 52. And take it away from 180. So, of course, this is 38 degrees. Therefore, this is 38 degrees. Measure of a central angle to its arc the same. If you just keep that in mind, watch out your diameters. Let's do a couple more problems here together. We're going to stretch out the diameters, RU and SV, trace, stretch, sweep. So RU, trace, stretch, sweep. We've got 180 going that way. And then we have SV, trace, stretch, sweep. We have 180 going that way. Knowing that, we're going to find the following angles and arcs. Before I go down this list, I'm simply going to find everything that's possible right off the bat. And if I look at that yellow and that's 180, if this is 130, I know this automatically is 50. Now we're going to do this. This is a central angle. Measure of a central angle to its arc the same. So I'm going to immediately just start labeling stuff. This is 86. I can bring this. Looking at the red, I can do 50 plus 86, and then we're going to take that away from 180 to get this squiggle here. $136, take that away from 180. Of course, we get 44, and then this is 44. And if you look really carefully, these two right here, don't overlook the obvious. Oh, looky there, back to vertical angles, way back at the beginning of the semester. And if that central angle is 50, that arc is 50. Notice, I just found everything possible before I even went to the list. You should make that a habit. Just find everything you can find and then go to the list. Let's see here. We're being asked to find U, Q, V. U, Q, V. Put your pencil on U. Go to Q. Go to V. Oh, we already found it, folks. That's 50 degrees. Now we're going to find arc, RTD. Very important to go in that exact order. Ready? Start at R. Go through T all the way to V. That whole arc from here to here is 180 plus 50. That's going to be 230 degrees. So that arc, notice it's a major arc, so it's bigger than 180, is 230. Let's follow this order. So VRT. So V, go through R all the way to T. Notice what we're going to add up here to get that. We're going to add 130 plus 50 plus 86. So the measure of that blue arc is 266 degrees. Make sure you follow the exact order when you do major arcs. Just trace and then simply add everything up. Another example. Okay, so right here, again, once again, let's start by stretching out our diameters. KH, trace, stretch, sweep. And JG, trace, stretch, sweep. And the ambition is solve for x and find all possible arcs and angles. And at first off, it doesn't look like you can solve for anything, but if you look really carefully, folks, really carefully, don't overlook the simple stuff. Retrace these two diameters. Retrace them. Wherever you have straight lines, you have vertical angles. I did that. That means those two angles are congruent. So we just figured out that this 9x plus 5 plus 10x is going to equal 100 degrees. So I can come over here. Let's do that. 9x plus 5 plus 10x is going to equal 100. Solve for x. Now, once you have that, and if you need to, check 19 times 5 equals 95. Now you're going to take that value of x. Remember, this is not algebra class. You don't end at x. Let's find the measure of each of these angles and then all other possible arcs and angles. So 9 times 5, that means that arc right there. Of course, is 45. And that means the central angle is 45. 10 times x plus 5, that makes that, of course, 55. Which makes this 55. Now, we still have a couple left here, but if you look really carefully, a couple arcs and angles left here. Remember, that is 180, friends. And if from here to here is 100, you should easily be able to get these guys. Which of course is 80. Which makes this central angle 80. Which makes its vertical angle 80. Which makes this minor arc also 80. So much information, guys. So don't overlook vertical angles. Watch out for those. Straight lines. Anytime you have two intersecting straight lines, you have vertical angles. This last page you're going to do on your own. Pause the video, do all the work, and then restart with a red pen in your hand. Do not copy. Do your own work, and then check with a red pen. Pause. Welcome back. Let's see what you understand so far. If this is 106, that means this is 106. I see straight lines here, which means this is 106. Split in half, 53, 53. 106 away from 180. That means this edge is 74, 74, 74, 74. Now that I have all the basic arcs and angles, now I'm going to do the major arcs. We're looking for F, H, D. Starting at F, we go through H all the way to D. And that's basically 180 plus 53. So that first major arc is 233. Next one, HDF. So we start at H. We go through D all the way to F. You see we hit that 180 again, plus 53. It's the same thing. This one, FDH. So we start at F. We go through D all the way to H. You see we have that 180 again, plus the 53. Looky there, it's the same thing. Check your work, folks. I should see red markings and red pen. If you're correct, I expect stars and smileys.